Okay, welcome everybody. This is GPSTEC319. I'm Santiago Cardenas. I'm a Partner Solutions Architect on the AWS Quick Start team. Just a quick show of hands, who has worked with or heard of AWS Quick Starts? Okay, a few of you. Also, another quick show of hands in here, who are AWS partners? Okay, so good amount. And I assume the rest are customers, AWS customers? Okay. So in this particular breakout session, we're going to talk about build once, deploy many. And what we're going to focus on is architecting and building automated, reusable reference deployments with AWS CloudFormation. So in this particular talk, I want to share with you things that we've learned from building over 50 different reference deployments. So just to get started here, what we want you guys to do is really to work smarter, not harder. On the left-hand side, on the left corner, we can see there's a lot of servers, a lot of things that need to be configured. On the right-hand side, we have a human. So while this is not a data security session, by automating a lot of deployments, we can reduce the human factor of configuring all these components, and thus reducing all the human errors that could happen. So typically, for anybody as an IT, whether it's a system administrator, a DevOps engineer, or anybody that's really running production services, aside from maintaining those services and making sure they're up and running, the other time is spent usually with some business problems. All different business problems are different, they're unique, but it usually starts out with discovering solutions to these problems. So you may go out to AWS Marketplace, you may talk to a reseller, a partner, a vendor, you'll get a demo from them. Once you get a demo, you'll try it out. Maybe you'll deploy a POC, talk to different stakeholders, get some user acceptance testing. Once all of that goes through, you move into deployment. You go out and deploy it in production. Maybe you deploy it first to a staging environment, prepare your pipelines to get it deployed, and then you actually deploy it in production. Your users start using the deployment, the services that have been deployed, the workloads that have been deployed. And then you go back to discovering. There's more business issues, maybe with the existing deployment, maybe with new business problems. So AWS Quick Start aims to solve all these different pillars in different areas. So to talk a little bit more about Quick Starts, they're automated reference deployments on AWS. So they have a reference architecture, they have an architectural diagram, a deployment guide, and a set of automated assets to actually help streamline the installation and configuration of key workloads on AWS. We are part of the AWS Partner Network. So we work with a lot of partners, like a lot of you that are present. And we're primarily a technical program. We're not really a sales lead generation program. We're really out there to serve customers. So we really focus on customers. And jointly, our joint customers, we try to create that success. So we have a quote there from Brooks Brothers. They use one of our quick starts, the AWS SAP HANA. And just with a push of a few buttons, they were able to get a functioning SAP HANA deployment on AWS. We have quite a wide spectrum of quick starts. We work with smaller partners, larger partners. We work with both with partners and AWS Solutions Architects to create all these different reference deployments. By the way, if you're a partner and your logo is not up there, we'd love to see you up there. We'd love to work with you and build some reference deployments on AWS. So quick starts really also aim to reduce complexity. A common question that we get asked is, how do you build a VPC the right way? This is an example. So if you were to build a VPC that's scalable, multi-AZ, that's got different subnets, you run over 100 steps just to do that. However, if you take the VPC Quick Start, it's usually 3 simple steps. Sign up, sign into your account, choose a key pair in a region, so you set up in a particular region, and launch the Quick Start. Within a few minutes, you'll have a fully scalable VPC that's all laid out with different CIDR blocks, set up with private and public subnets, and the works. So what we're going to focus on this particular talk is the different phases of development. How do you build a reference deployment? While all these particular phases are not always left or right, sometimes they'll happen in parallel. As part of this discussion, we're going to go first, second, and third. And we're going to spend a bit more on build and test. A lot of the things that I'm going to talk about here are not an exhaustive list or a complete list of all the best practices, but I will rather give you some key tips and tricks and some design patterns. Just to keep, also to do these tips, tricks, and design patterns, you can explore them and take action right away with some of your deployments. So feel free to take photos, but just keep in mind that the slide deck will be posted online along with the video. So you'll be able to explore it later as well. So let's get started with plan and design, which is kind of our first phase of creating a reference deployment. So before we dive into some tips and tricks, I want to talk to you a bit of an anecdote. So we work with 47lining and Tableau. 47lining is an advanced consulting partner. Tableau is an advanced technology partner. And they're both part of the AWS Big Data competency. So we set out to build a reference architecture, a reference deployment for a modern data warehouse on AWS. Then the interesting thing about this particular deployment is that it was a new use case-based quick start. Most of the quick starts that we had built before, 40 plus, they were all around the key deployment of a partner's product and the architecture that goes with that. This was combining some AWS services with partner products all together in the mix to create a modern data warehouse. So what we did up front was really try to define the scope and the organization of all the assets. And with that, we built some very clear architectural diagrams that defined, we have an instance here, a subnet here, security groups over here, in all the different services. So that really helped a lot, and it was a really successful quick start that's widely used today. So around architectures, there are some key attributes about great architectures. Great architectures are secure, they're reliable, they're performant, highly performant, and very efficient. So we're going to dive into some tips and tricks on each one of these. So for security tips, you always want to lock down your external admin access. So if this is SSH, RDP, make sure you have a CIDR block that you consider that you'll be able to provide a user that's using this reference deployment. So they can put their CIDR block for whatever their corporate firewall or whatever their access is from their corporate data center. You want to implement the security groups with principles of least privilege and role-based access. So what we mean by that is just open the ports that are necessary. Don't open any extra ports if they're not needed in the particular security groups. And role-based access means if you have a set of web servers, create a security group for those. And let's say you have some application servers, they need to have access from the web servers. Make sure you reference that web server security group so they can access the application level security group. So each set of instances has their own role. Never use default passwords. This is pretty obvious, but at least provide a way to set one. If you do set up a default password, upon first logon, you should automatically ask, let's change the password. Use public and private subnets. So if you're not familiar with public and private subnets, public subnets have direct connectivity from the internet via the internet gateway that's attached to the VPC, while private subnets have no direct access. So this is where you put a bit more sensitive workloads, like databases. You put them in the private subnets. Public subnets, you would put things like load balancers or your web servers. Avoid outputting secrets and logs. And if you do, for whatever reason, make sure you go back and scrub those logs. Also implement ways of auditing access and usage. So if there happens to be a breach, if there happens to be some misconfiguration, you can always go back and look at who's accessed it, who's used it, and be able to find the root cause. Now, in terms of reliability, make sure your architecture spans multiple availability zones. Availability zones are like fault domains. They're really separate fault domains. So if one availability zone happens to have a volcano next to it, the other one doesn't. So it really separates those fault domains. Consider multiple regions for disaster recovery. So with this, your mileage may vary. It's really a decision to balance cost versus risk. But if you do, and if you do need that disaster recovery in your architecture, make sure you consider that as well. Always create regular snapshots of data. So in case you need to recover from that disaster, you want to make sure you reduce your RPO as much as possible. So having valid and tested snapshots of data is truly important. Make sure you implement health checks. And not just simple, is it up, is the instance up or down or responding, but really more meaningful health checks that actually check out, is my server, serving content. And if there is an issue, make sure that you remove and replace these problematic nodes. We just had Cyber Monday yesterday. This is probably the most important item out of all. Make sure you can scale up to handle additional load. So if more requests are coming in, make sure you have the right alarms, the right events that trigger this scale up in a fairly quick fashion. Now, in terms of performance, make sure you deliver some of the static content from edge network locations. This is really super easy. There's a lot of strategies around it. CloudFront is great for this. Now with over 100 points of presence worldwide, it's really easy to get that set up. In terms of caching, again, this a little bit, it varies from architecture to architecture, but you really want to cache at multiple levels, whether it's at the particular node, whether it's a very close cache, maybe using Elastic Cache or Redis, or maybe it's a DynamoDB database. Make sure you do a little bit of caching where you can reach the data very quickly. And with that, with caching, make sure to avoid storing state in compute or app level instances. We talked a little bit earlier about health checks. If a node happens to go down, you definitely don't want to have any session state in that, because if you're replacing that node, then that means the user experience is they've automatically logged out. They'll have to log back in, and that's definitely not a good user experience. So for that, you could use something like maybe a caching server or a caching cluster, or maybe DynamoDB will also be a great option for this. Try to utilize the high performance features of load balancers. So if you have an auto-scaling group, you probably want to have a load balancer in front of that, so you'll be able to load balance across the different nodes. And a common feature that is used in some of the load balancers is SSL offloading. So that's one of the great features there that a lot of customers tend to use as part of offloading. As part of the high performance features. Try to select always the right instance types. If you have an in-memory database, you probably want an instance that has a lot of memory. If you have maybe an instance that needs more compute power, make sure you get that ratio right. So want to try to test out a few different instances, find out which one is the best for your particular architecture. Take advantage of high performance database services. So if you have relational databases, make sure you look at Amazon Aurora. If you have NoSQL databases, DynamoDB is probably a great fit. They're all managed services, so they're usually a very great fit to lower that operational cost. Now, in terms of efficiency, just the opposite of scaling up. Make sure you can scale down. So Cyber Monday is coming, it's long gone now. Yesterday happened. So make sure you scale down now. So now is that if your customer demand is reducing, that the event has happened, or maybe with Super Bowl and you're serving more videos, you're serving less videos now, or less commercial, less traffic, make sure you scale down. And you want to do this also in an automated fashion. Just like this scale up, base it on events, an alert, and then take an action. Try to explore containerized solutions as well. This allows for higher compute density. So looking at containerized solutions allows you to put more processing into less instances. Separate some of the constant load versus the bursty load. So if you're looking at constant load, things that have to always be up and running, you can take a look at just reserved instances will be a great fit here for efficiency. And in terms of bursty load, spot instances, exploring the spot market could save you a lot of money. Take a look at AWS Lambda for some of the serverless components. So if you have some operations that only happen maybe hundreds of times a day, you probably don't need an instance running the whole time, all day, 24 hours. So definitely, you can also be very efficient by using some of the serverless components. Try using some of the managed servers that we have. So I mentioned Aurora, and I mentioned DynamoDB, but RDS in general, EFS for storage, NFS storage, directory service for identity management. Those are all great services that are managed for you. And really, you don't have to worry about patching. You don't have to worry about, are the servers up and running or not? So it really gives you, it lowers that operational burden. So if those 4 items that we talked about sound familiar, they actually fit very well into the well-architected, AWS Well-Architected framework. So if you haven't explored this, it's really worth a read. There's a great set of white papers on this. I didn't talk about operational excellence. We're not focusing here around patching and monitoring, so we're not covering that directly. But it really fits very closely, so I highly recommend to check out the AWS Well-Architected framework. If you're a partner and you're looking to get some of the competencies, this is actually our requirement. You must pass or go through a AWS Well-Architected framework review. So let's switch gears a little bit, and that's where I said we were going to spend a bit more time on is building and testing your reference deployment. So as we built 50 plus different reference deployments, we've seen some recurring themes. So we've seen a lot of scripting, and scripting involves configuring, installing applications and services. It may include things like Chef, Puppet, Ansible, and configuration management tools. We've seen a lot of orchestration that takes place, and this is to deploy and manage the life cycle of all the AWS resources and services that are deployed as part of the architecture. And we've heavily used source control. And this kind of rounds out the infrastructure as code process by capturing the version and revision history. So you can always go back if there's an issue. You can always check what the differentials are between the different versions of the architecture. So let's talk a little bit more about some of these. Starting with scripting. Quick raise of hand. Who works with Linux a lot? Okay. What about Windows? Okay. What about both? Okay. Okay. So you've probably seen there's a lot of differences between both of them in terms of bootstrapping. So for package management and installation, you'll see that in Linux you'll have yum, apt, zipper, depending on what distribution you're using. On Windows, it's normally a Windows installer. You'll have an MSI package, an exe. Now, a great open source repository is Chocolatey. A lot of people are using that today. In terms of scripting, we normally see in the Linux world, we see a lot of shell scripting, a lot of Python as well. On the Windows side, we tend to see a lot more Windows PowerShell. It's kind of a first-class citizen on the Windows ecosystem. It's already pre-installed, it's already set up. In terms of configuring some of the applications and components, on the Linux side, we see a lot of file-based configurations. On Windows, we see a lot more using the Windows registry to set particular settings for different applications. In terms of configuring, a little bit more configuration, we use a lot of command line utilities in Linux. While on Windows, we use a lot of commandlets that come from PowerShell modules. And of course, in Linux, we see a lot less reboots. On Windows, whenever there's a system-wide change, you have to make sure you account for that reboot. So we have user data on instances, EC2 instances, and this gives us the ability to execute scripts when the instance is launched. So I have an example. It's a bit of an eye chart, but I'll go over all of the components here. And for Linux, we normally start out with, and this is really a design pattern here. This is not really a script it could be copied verbatim, but it's really more of a pattern. It starts out with specifying that we're using bash as the interpreter for this script. We set up some extra paths so we can account for some of the tools that we'll be installing later. We make sure we update the operating system. So make sure yum or apt-get, depending on what we're using. We installed Python pip, so package management for Python. If it's already there, we make sure to upgrade it to the latest version. Then from there, we installed the AWS CLI. And we'll use that to connect to any, or actually send any calls to the AWS APIs. Then we'll install the CloudFormation bootstrap tools. This will give us then CFN init, which we use for configuring, and I'll talk a little bit more about this later. Then we finalize with CFN signal. If you see some of the text there in purple, it's really parameters that are being resolved from the CloudFormation template. So this particular code block will be in a CloudFormation template. Now for Windows, it's a little bit different. We just say that this is a PowerShell script, and we're calling CFN init. And again, the purple items on there are resolved directly from the stack. So you might think a bit of what happened to the updates, AWS CLI, CFN helpers, CFN signal. Well, it just happens that on the Windows side, we unpublished the AMIs that are older than 2 months. So you always have a fresh AMI whenever you're running something here for Windows, or you should have one. For the AWS CLI, we normally use the PowerShell modules, the PowerShell tools that we provide for AWS PowerShell. The CFN helpers, the Bootstrap helpers are already pre-installed on any base AMI for Windows that we provide. So you can just call CFN init. And CFN signal gets called within CFN init. So this is a bit of a callback to the reboots that I was mentioning. So the reboots will be handled by CFN init. And then at the end of CFN init, then you send a CFN signal that the instance has completed configuration. Amazon Linux also includes a lot of the tools. So if you're using Amazon Linux, your user data might be a little bit smaller. But in general, for Windows, it's really this small. So as part of the AWS Quick Starts, we found ourselves performing a lot of common operations across Windows architectures and even Linux architectures. So on your left-hand side, you can see how we handle a lot of the signaling that happens in the CloudFormation stack. So we created a module, and we have a few commandlets on there. So we have some initialization commandlets that handle wait handles and resource signals and saves them in the Windows registry. And then when you need to finalize, so you're done with bootstrapping the particular instance, you can either signal if it's a failure, signal an exception, and basically capture the exception and signal the failure. Or you can just say, I just want to write the status, whether it's good or bad status, and it'll send it up using CFN signal. On your right-hand side, you can see some of the scripts that we created. Common themes there, join domain. We see a lot of joining machines to the domain, renaming the computer, downloading a file, just common items. So you can see there on the screen, we have the URL. This is open source, all these different scripts and modules. And we also have some for Linux. They're just not as mature as the Windows ones at this point, but we're continuously adding more and more features to those. So let's take a look at a bit of a design pattern here around Windows PowerShell scripts. So if you're familiar with try-catch blocks, here's a way that you can build a PowerShell script for configuring an instance via CloudFormation. So it usually starts out with a parameters section. These parameters will be fed in from the CloudFormation template. So when the script is called, it'll send a value for parameter 1, parameter 2, however many parameters you have. Then you move on to the try block. You want to set error action preference to stop, so you can catch any non-terminating errors. Then you do whatever configuration you need to do as part of this instance that's executing the script. If any error happens, goes right to the catch block. The exception is caught and then is fed over to the commandlet that we talked about earlier, which catches an exception, processes that exception, saves a copy in the Windows logs, and then sends a signal to CFN to tell it to halt the stack. There's a problem in this particular step of the execution. So this is a good pattern to follow in the scripts. In terms of configuration management, you can definitely improve your scripts. So making scripts reusable is great. Making them rerun in place is really ideal. So we have a lot of AWS partner solutions that can help with that, from Ansible, Chef, and Puppet. Or if you just want to keep it on, if you're on the Windows side mostly, and you want to keep it just plain, PowerShell DSC is also a great option. Let's switch over a little bit more to the orchestration side. So AWS CloudFormation gives you a declarative way to create and manage a collection of AWS resources. It understands dependencies, supports rollbacks and versioning. It also allows you to create reusable modular components. And it supports JSON and YAML. So taking a look at a bit of a look at the template anatomy for a particular CloudFormation template, there's only one item that's required, and it's the resources. It's the only mandatory section. And the reason why I put it there in the middle is I will show you the order where normally we typically see templates being organized. And if you think of it as a program with some programming concepts, you'll see that the AWS template format version is like a schema. Then you have things like description and metadata, and those are like the interface. Think about the interface of a program. You have parameters, which is the input. You may have some mappings. This is the configuration settings. We typically see here AMI mappings or configuration of this much memory allotted for a particular process, or any type of settings that are needed for that architecture or that instance. Then you have conditions. These are like conditional statements. The great thing about these is you can tell it to create a resource or not create it based on the inputs and evaluating a condition. Then you have rules. You may not be familiar with rules. That's because they come from AWS Service Catalog. These are great template constraints, and you can basically allow a template to not be deployed in a particular region, or that you have to use a particular instance type, and things of that nature. You also have transforms. Most common transform is the serverless application model. There's also another one that's called AWS Include, which you can have a separate CloudFormation snippet and pull that into the template at execute or at deploy time. Finally, just like a program, you have outputs. And these are just to show relevant information to the user, such as the URL of my deployment, like where do I connect to? What is the VPC ID? Things of that nature. However, once you have this template, you create a stack. So in AWS CloudFormation, it's all about the stacks. And a stack is a single unit to manage related AWS resources. You can create, update, and delete any resources by creating, updating, and deleting a stack. Stacks are created from templates, as I mentioned a second ago. You could also use change sets, which create a series of deltas that you can apply to your stack, and you can evaluate them before you apply them. And you can virtually manage any kind of AWS resource. Then as part of the orchestration, you saw earlier that we were calling CFN init. And this is a really useful helper script that consumes some of the template metadata and enables you to call a variety of scripting languages. So you could use things like, as I showed in some of the examples, you can do some shell scripting, you can do some PowerShell calls, you can call an Ansible playbook, and you can create call a chef recipe, whatever it is. You can actually call whatever you like. There's two main sections to the CFN init metadata. Credentials, or typically roles, are stored in the authentication section, and the configuration, or all the steps and stages, are stored in an init section. This executes as root or on Linux and local system on Windows. So then you can impersonate a different user if the configuration needs a particular user to be used for installing a particular process. So let's take a look at an actual example of an authentication section. In this particular authentication section, we've said that this is a type of S3. So these are credentials that we would use to connect to S3. We're using a role name. So we're using a particular role that's defined in the template. We call this some host role, and we're just referencing that. And then optionally, you can specify the buckets that you want to use for your sources. And sources is a section of CFN init. There's all the sections that I'll go over in the next few slides. But you only have to specify this really for sources. An example of a Linux init files section. So this is for the init section. You have a config piece of this configuration, which sets that this is a config set. Then you have your file section. This then tells you what the local file name should be when the file is created. So we're calling it in the temp directory. We're creating some script.shell. In this case, we're saying source this script from some location. Then we use an fn sub, like a substitution function, to dynamically build a URL using some parameters from the template and getting a script that's called script.sh. At the same time, once the script is pulled down, we set the permissions on that file. And here is where we use the authentication credentials that came from the other section. So it assumes that role, gets some temporary credentials, downloads the file, and off it goes. Now, in terms of a command section, also in the part of the init, we just talked about the file section. So usually right after the file section, you may have a command section. These are in alphabetical order, so we can call it whatever you like. So we call this do the first thing here in the configuration. We call a particular command. This command is we're using a sub function to dynamically build the command. And we're calling that script that we downloaded earlier in the last slide. We're passing a parameter that comes from the template. So you're familiar with the curly braces with a $. That's resolving a parameter or a resource from the template. And we pass that parameter right into that template. Then we may perform another action right after that, another command. And this command basically just, let's say it just creates a file just to signal that maybe something is done, and moves along. This is just an example, really. So in terms of source control, it's very important to organize the assets. So you'd want to define a strategy for organizing the assets within your repository. What you see there on your right-hand side is how we normally organize quick starts in our repos. We have a CI directory where we stored a lot of the CI pipeline specific files, some configurations, some parameter files, and whatnot. We have a functions directory where we store Lambda functions and their source code. We have a scripts directory where we store any configuration files, shell scripts, PowerShell scripts that are part of the configuration. We'll have some modules, which I'll talk in a little bit more about. And then we have the templates directory where we store all the CloudFormation templates. And then we just so happen to have a license there. All of our quicks are Apache 2.0 licensed. We have a quick notice and a README. So really, this helps you keep all the files in the expected locations. So if you're running this through a pipeline, then you know exactly where your templates are at, where your scripts are at, and you can build a lot of different URLs a lot easier. You know exactly where everything's located. Making use of submodules for common code is very useful. So we use a lot of the Git submodules functionality to be able to pull some foundational quick starts like VPC, maybe a Bastion host, maybe RDP gateways or remote desktop gateways. Pull them all into one larger architecture. Always avoid storing bits and binaries. So if you need to compile something, you want to make sure you compile that on your CI pipeline or your build system. An example configuration and parameter files for our pipelines that we use for quick starts. You can actually model your pipelines for this, for your reference deployments as well around this. We use GitHub. We have Jenkins servers that are watching the GitHub branches, run some tests based on the file that you see there, and then publishes to S3. The configuration file normally has a set of regions where we run the tests. So if there's some changes to the templates of the reference deployment, picks up all the changes, and knows where to run the test, which regions to run it. Then it uses each one of these test sections to say, well, I want to run this particular template entry point with this parameter file in these particular regions. So the parameter file is a separate file, and it'll have all the answers that it needs to pass to that stack as part of the test. And we also have a lot of custom generators. So you can see there availability zones, like the first one. We have a little key there that says, get me 2 AZs from this account that you will use as part of the deployment. Same thing for passwords. We generate the passwords on the fly for each test. We also have an open source tool called Taskcat, and it's an AWS CloudFormation launcher and tester toolkit. A lot of our partners are using it. We're getting a lot of great feedback. It's compatible with many of the features that we have on our CI systems today that we use for Quick Start. It's currently in beta. It's a work in progress. So we're still trying to add more feature parity with our CI systems. But it's already open source. So we already are accepting pull requests. We're already working with partners to make it better. And it's available on our GitHub organization under AWS Quick Start Taskcat. So it's really, really easy, really cool to test a lot of the CloudFormations, every time there's a change, your pipeline could pick it up, use TaskCat to run the tests, and then creates a quick report of what passed and what failed. All right, so this is the last section that we have here, the last phase of development, which is optimizing and enhancing. And we'll go over some more tips and tricks around this. So some attributes of great templates. What we see in a lot of different templates that we've built for reference deployments, and what we try to do is make sure that they're maintainable, longer term, make sure that they're flexible, reusable, and standardized. So I'll go over some tips and tricks around these, some tips and tricks that you can take action right away in some of your templates and deployments. So in terms of maintainability, you always want to store everything in source control, some source control systems, and keep them version. That way you can go back and see what the differentials are, make sure that if there's a regression that was introduced, you can revert back to a version. Ensure that the testing can be easily automated and happens on a recurring basis. So great templates allow you to do this. So it allows you to create a parameter file. You can use a CI pipeline to run some recurring tests every time there's a change. Implementing stack nesting is great if you are packaging all the assets together. If you're not, if you're using one template here, one template there, then nesting may not be needed. Make sure you use intrinsic functions to resolve and combine some of the properties and parameters. So all of these different ref, join, sub, get attribute, they're very useful. As we saw in the examples earlier, we were building the URLs to download the assets dynamically with relative paths. So definitely make use of intrinsic functions. In terms of flexibility, as I mentioned, relative paths allow you to resolve external template assets. So if you have scripts, configuration files that you have to pull in for the particular configuration, relative paths definitely the way to go. This also helps you with allowing you to move the asset to a different S3 bucket. So let's say you created a deployment in one particular region and you want to use a bucket in another region, or maybe if you're a partner and you want to provide this to your customer, and the customer wants to edit it and build on top of that reference deployment, then that means they're going to have it in their own S3 bucket. So by using all these relative paths, it allows you to change a few parameters in the template and then build all the directories or all the URLs accordingly. Flexible templates are driven by parameters, mappings, and conditions. I mentioned a bit earlier, the conditions are great, allows you to deploy or not deploy resources based on some parameters, and the mappings allow you to have different configurations saved. Omni's being the most common one. Flexible templates also run on multiple AWS regions or accounts, really, and it could also happen concurrently. So with that, you want to make sure that you're able to deploy in all the different regions when you do your testing as well. Flexible templates will also support AWS GovCloud. And this normally happens via conditionals. So the way we write a lot of the quick starts that support GovCloud, there'll be a condition that says, are we in GovCloud, just by detecting the region? And if it is, then all the relative URLs that are built are tweaked accordingly for all the AWS GovCloud URLs. In terms of reusability, you want to ensure that you are supporting new and existing VPC deployments. It may happen that a customer will have a new account, new region, and you want to make sure that they can deploy from scratch. Some customer may already have a VPC, and make sure your workload can be deployed in an existing VPC as long as it meets the requirements that you need for a particular, for your deployment. Let's say you need private subnets, public subnets, etc. Reusable templates are also based on roles. So you may have a template that deploys the web servers, a template that deploys the databases, a template that deploys the networking, etc. I've brought this up before, some modules. Really useful way to use common templates. So if you have a reference deployment that deploys a higher level or a more comprehensive architecture, you can use more foundational templates to do so and pull them in as sub-modules. This also allows you to create or combine multiple templates and build larger, more complex deployments. So if your customer wants to use some type of database workload and combine with, let's say, an application, some other application workload, they can pick and choose from different templates. Make sure you don't use any named resources. This goes along with being able to deploy in multiple regions. If, for example, you're using IAM roles or S3 buckets, as you may know, or you already know, these are, they're globally unique. So if you deploy an S3 bucket with a particular name and an account, and you're using a named, or a name for that bucket, first of all, you may fail on the first deployment if that name is already used. And if you already were successful in deploying that, the subsequent deployment will not work. So definitely try to avoid. CloudFormation will dynamically generate these names for you. So it's good to make use of those features. Great templates are also standardized. So maybe funny or not, but settling on spaces or tabs or any other coding conventions is really useful. It actually helps with a lot of the maintenance. So beautifying your templates and enhancing the readability. So one of your developers may be creating the template, but maybe somebody else is helping maintain it. So having some standardization across different ones, it's definitely useful for long-term maintenance in the end. Some sensible and common defaults across architectures. So if you're using CIDR blocks, make sure you standardize on those. That way it allows you to combine it with a different architecture. If you're doing things like, if you're doing a CIDR block, make sure it's a CIDR block that's flexible enough that you can add more servers or instances later if needed. When it comes to AMI mappings, you want to make sure that you have those specified in your template. AMI mappings will help you with multi-region deployments. So if you need to have your template support, US East 1 or US West 2, if you have those AMI mappings in there, it also allows you to automate some of the maintenance. So you can, create a quick script that looks at the template, finds which AMIs may have changed, and you can update them. So just to recap everything here, the job is never done. But what we've done here now is we went over plan and design. We talked about secure, reliable, performant, and efficient architectures. We went through building and testing, and we explored some code examples around scripting, orchestration, and we also talked a little bit about source control. And we cover a phase of optimizing and enhancing. We just went over maintainable, flexible, reusable, and standardized templates. And like I said, the job is never done, so you may have scripts that you want to cycle back and take a second look. For the AWS Quick Start catalog, we're at aws.amazon.com/Quick Start. You'll see there are a lot of key workloads that you can make use of right away. We're also on GitHub. I mentioned that earlier. Everything that we create as part of AWS Quick Start is open source. Everything's Apache 2.0 licensed. In TaskCat, the tool that I mentioned earlier, as well as every other Quick Start. And we're there at AWS-Quick Start is the name of the organization. I have some further reading here, slides that you'll find in SlideShare once all these are shared. And it's got a lot of different links that you should read. They're actually very useful as part of creating these deployments. And with that, I want to thank you. Thank you for joining the session. And I'd like to open it up for some Q&A. And also don't forget to fill out your surveys or your evaluations. And any questions that you may have? Questions? No questions? Thank you very much.